Okay, students. So let us start today's session. In our last session, we learned about bitwise operator concept. Bitwise AND, bitwise OR, bitwise XOR, then left shift, right shift, and of course, left shift and right shift of positive numbers and negative numbers, followed by bitwise complement also we discussed. Now, let us practice some question from this bitwise operator. Say for example, suppose here I'm writing one code here, say unsigned int I is equal to 0x80 followed by printf statement printf here %d and then I left shift by 1. Now here it seems a very easy problem statement, but so many things we need to discuss before we can go and attempt to solve this question. So what are the important point here is, first is, what do we mean by unsigned integer? What do we mean by unsigned integer? Or let it be. Suppose for example, whenever we are dealing with integer, for integer, size of integer is 2 bytes. Always, no, not always. Sometimes it may be 4 bytes also. So either 2 bytes or 4 bytes. Depends on the compiler. Size of integer is 2 byte or 4 bytes. Depends on the compiler. Now, suppose for example, currently we are considering about 4 byte integer. If it is a 4 byte integer, you observe carefully here. For 4 byte integer, this is the range. 4 byte means, guys, 32 bit. 4 byte means 32 bit. 2 byte means 16 bit. So 4 byte integer means 32 bit. And this is the range. Minus 21, 47, 48, 36, 48 to 21, 47, 48, 36, 47. So what is the range for 4 bytes? Minus 21, 47, 48, 36, 48 to 21, 47, 48, 36, 47. This is the range of 4 byte integer. But this range is a signed range. This range is a signed range. Why so? Why signed range? Because you bring sign into picture, na? Positive, negative. Sign you bring into the picture. Sign you bring into the picture. That's why it is considered as signed range. Now, if I try to pictorially interpret this particular range, if I try to pictorially, diagrammatically interpret it, then how it will look like? Two side is there, positive side. Nothing is mentioned means positive side. Another is negative side. So in the positive side, from 0, 1, 2, dot, then 21, 47, 48, 36, 47. That is the positive side value. Similarly, minus 1, minus 2, dot, minus 3, dot, negative side last value is minus 21, 47, 48, 36, 48. See, minus 20, minus 21, 47, 48, 36, 48. This is the negative value. This is the last negative value in the negative side. Now, as because sign, positive sign, negative sign, it is there. That's why it is called as signed representation. That is why it is called as signed representation. The same thing, the same range, if I go for unsigned, The same thing if I go for unsigned, for the same 4-byte integer, the range will become 0 to 42, 94, 96, 70, 42, 94, 96, 72, 95. This is the value. This is the value. So how to remember? If you remember this one, this is very easy to remember. How? To multiply 21 with 2 times 42, 47 2 times 94, 48 2 times 96, 36 2 times 72, 47 2 times 94 plus 1, that is 95. Just that plus 1. Last one 2 times or plus 1, 95. So very easily you'll be able to remember this. Now, once this is the representation of unsigned, then its pictorial representation is something like this. 0, 1, 2, dot, dot, dot. No sign, nothing. No sign, nothing. Last value is 42, 94, 96, 72, 95. This is signed and unsigned of 4-byte integer. Unsigned representation. This is signed representation. This is signed range. This is unsigned range. This is unsigned representation. This is signed representation. This is signed representation. Now you see the beauty, guys. Say for example, forget about this code. I will bring this later. Say for example, guys, I took one integer here. I took one integer here. Int I is equal to, I'm taking this value, guys. Last value in the signed range. What is that? 21, 47, 48, 36, 47. This is the last value in the signed range. Na? This is the last value in the signed range. Okay. Now I want to print that value. I want to print that value. What is the problem? Easily I can print that. Na? No problem. Let me print that value. Printf %d I. Printf %d I. What will happen, guys? The value will be printed. This value will be printed. This particular value will be printed. Where is the proof, sir? Execute, compile and run. Acha, compile and run. Execute, compile and run. The value that we expected is getting printed. The value that we have inputted here is getting printed here. Now observe very carefully, guys. I made a small change here. What is that? I made 48. Now see, students, in the positive direction, means in the positive side, do you really have the existence of this value? Do you really have existence of this value? No, sir. Up to 47 I have. Up to 47 I have the existence. But 48 I don't have. Then 48 will be where? Other side, na sir. Other side. 48 is other side. But if you go to the other side, this is negative value, na? This is negative value, na? -1, -2. How far? Sir, this one. 21, -21, 47, 48, 36, 48. This is the negative value here. But you give what? Positive 48. Then after this, but after this positive 48 is not there. What is there? Negative 48 is there. So it will pick up that value. It will pick up that value and it will print the negative value. Check it out here. Execute, compile and run. (21, 47, 48). Not 35, guys. 36, 48. Let me compile and run one more time. Execute, compile and run. See these, guys. What value it took? Minus, na? But I entered what value? Positive. I entered what value? Positive 21, 47, 48, 36, 48. But it is taking which one? Negative 21, 47, 48, 36, 48. Why? Because, sir, in the signed representation, this positive value, whatever you are taking in the I, in the signed representation, I don't have that. That's why what I did, I took the negative value, which is equivalent to this. Acha, then if it is 49, what will happen? If it is 49, sir, it is increasing now. One by one, it is increasing. 47, 48 means negative 48. Then you are going to this. 49 means, sir, it will be negative 47. 49 means it will be negative 47. Really, sir, check it out. 1 minute, guys. Check it out. 1 minute. Yeah. See this. Execute, compile and run. Negative 47 na, guys. Sir, if I make it 50, then minus 46 will come na? Yes. Execute, compile and run. Okay na, guys? Perfect na? Sir, that means if you are talking in terms of unsigned, now what will happen? This is signed. If we don't write anything, guys, by default it is considered as signed int. By default integer is considered as signed int. I want to make it unsigned. Then you have to write unsigned. Then you have to write unsigned. But if you don't write anything, sir, by default it is signed. See, guys, if it is unsigned and you are writing here 48, is it really exist? Yes, sir, it's exist. Then what will be printed? Sir, that one will be printed. That one means positive, na? Positive, sir. Achha, 1 minute. I didn't save the code, guys. Let me save this. Execute, compile and run. Achha. Whenever you are taking unsigned, guys, whenever you are taking unsigned, you have to change the format specification also. You have to change the format specification also. The format specification for unsigned is %u. The format specification for unsigned is %u. Now you see this. Execute, compile and run. Perfect, na? 48 you give, 48 is coming. Sir, if I take 49, 49 will come. Execute, compile and run. 49 will come. Sir, if I give 50, 50 will come. Positive 50 or negative 50? No. Unsigned, na? Positive 50 will come. Execute, compile and run. So that means what? Observe here carefully. Unsigned positive 48. Unsigned positive 48. It is actually equivalent to signed negative 48. Unsigned positive 49 is equivalent to signed negative 47. Same way, unsigned, this value, guys, what is that? 42, 94, 96, 72, 95. Sir, it is unsigned. The exact value will be printed. Yes, exact value will be printed. Exact value will be printed. But if I make it signed, you identify what is the equivalent value for this. What is the equivalent value for here? -1. Oh, -1 will come now, sir. Percentile D, because now you are dealing with signed. Execute, compile and run. Okay, na? Sir, if I make 96, 0 will come. Execute, compile and run. Sir, if I make 97, 1 will come. Now it will be rotating in the circle. Execute, compile and run. Okay, now guys, this is the discussion of signed and unsigned. This is the discussion with respect to 4-byte integer. This is the range for signed. This is the range for unsigned, and these two are diagrammatic representation of signed and unsigned respectively. Okay, now let me go for that original example. I'm removing this. Now here, which thing is unknown to you in the entire coding? This thing is unknown to you? No, not anymore. After that, no. This is not known to me. This is not known to me, sir. What it is? If a number is prefixed with, if a number is prefixed with, if a number is prefixed with 0 small x or 0 capital X, then it is considered as hexadecimal number. Then it is considered as hexadecimal number. Hexadecimal number means what, guys? 0 to 9 same as decimal. 0 to 9 same as decimal. After that we are having A, B, C, D, E, F. You can think small a or capital A. Both are allowed. Both are allowed. This is hexadecimal number. Now, whenever we keep any hexadecimal number here, whenever it will be stored in the variable, it will automatically convert it to it will automatically convert it to decimal number. It will automatically convert it to decimal number. If a number is prefixed with 0x or capital 0x, it indicates the number as hexadecimal number. It is considered, better to write, it indicates the number as hexadecimal number. But internally, whenever it will be stored in the variable, what value it will be stored? Is it the decimal value it will be stored, or is it the hexadecimal number it will be stored? It will be the decimal number. That means hexadecimal to decimal conversion it will take place, and then the number will be stored. How to convert hexadecimal to decimal? Very simple. 0x80. Now what you have to do is that you have to multiply first 0, that means the first digit, with 16 to the power 0. Why 16, sir? Because for hexadecimal, base is 16. For decimal, base is 10. For binary, base is 2. So first digit 0 into 16 to the power 0. Next, plus, what is the next digit? 8 into 16 to the power 1. So what is the final result? This part is basically 0 and this part is 8 into 16. That means what, guys? 128. That means what, guys? 128. So that 128, now it is becoming very easy. Now easily you will tell the answer. 128 left shift by 1. Will you take time to give answer now? Tell me, guys, what is the answer? 128 left shift by 1. Yes, Chetan, very good. Sir, it is 256. Immediately we can say that it is 256. Yes, perfect. 256. Now let us verify. Execute, compile and run. Okay, now. So what we have learned from this particular small coding, the coding is very small here, but you know, internally so many things we have learned. First, complete understanding of signed and unsigned. Then hexadecimal number, how it is represented, and if it is written, how to consider. Okay, guys, let us go for the next one. Monday onwards, I will share the documents with you. All the documents, whatever prepared till now. Monday onwards, every day I will update and I will share all the documents starting from beginning with you guys. No need to worry. Till now, whatever discussed, we have a record here. How many questions, guys? Such a numbering somehow is not continued here. I will update this by making it, giving the numbering and making the perfect document. Monday I will share with you. Okay, sir. So signed, unsigned, we completely understood. Let us go for another example here. Suppose, for example, unsigned int a is equal to 0x for hexadecimal, and I'm writing so all are f. All are f, because f, just now you have learned now, is a valid hexadecimal number. Okay. Next, and after that, unsigned int k is equal to complement of a, and then printf percentile d a comma k. This is the code I have to execute. Now it is very simple. How such simple? You see here 0x ff. What it means? 0x ff, what it means? You see here 0x ff. Now among this, f indicates what? F indicates what I said now? 0 to 9 is same as decimal. That means whatever decimal 0 to 9, same as hexadecimal 0 to 9. Same as hexadecimal 0 to 9. These two fellows are same. 0 in decimal, 0 in hexadecimal, both are same. But if you say 10 in decimal, that will be equivalent to small a in hexadecimal. 11 in decimal, this is equivalent to small b in hexadecimal. Small b or capital B, guys, that doesn't matter. So in this way, 15 in decimal, is equivalent to small f or capital F in hexadecimal. Okay, guys. So this f actually means what? 15. This f actually means what? 15. 15 in binary, how it looks like? 15 in binary. Sir, it will be 1111. It will be 1111. So how many f are there? 4 f are there. So that means the number will be 1111, 1111, 1111, 1111. This number's equivalent decimal number, will be the equivalent, this hexadecimal's equivalent decimal. How can we do that? Very easily. What will be the equivalent decimal number for it, guys? Very simple, sir. 1248 16 32 64 128 256 512 1024 2048 4096, guys, 8192 16384 65,536. 65,536. This is the value. 65,536. Is it 1248? No. 1 minute, guys. What is the value, sir? 1 plus 2 plus 4 plus 8. Okay, plus 1632, 64, 128. 1632, 64 plus 128 plus 256, 512. 256, 512. Next, 1024, 2048. 1024 plus 2048 plus this one, 4192 plus 2048 na, 2 times 8 into 2, 16, 9, 4096. Next, 8192. 8192. Where it is? 256, 512, 1024, 2048, 4096, 8192. Yeah, next. 16,384. Is it? Yeah. Plus last one. 32,768. If you take the summation of it, guys, you will get 65,535. If you take the summation of it, you will get 65,535. Later you will go for the addition. Anyone have the doubts, sir, why you started adding 1 plus 2 plus 4 plus 8? Anyone there? Sir, I didn't understand these things, sir. Confirm once in the chat box. Anyone there who didn't understand, sir, why you write those? I didn't got it. Good. No one is there. Everyone got understand. So what is the current value in decimal? 65,535. And that's an unsigned number, guys. That is an unsigned number. Okay. So 65,535 will definitely be somewhere in the positive side, sir. In this positive side, somewhere it will be there. Of course, in case of unsigned, everything is positive. Everything is positive. In case of unsigned, everything is positive. But while printing this A, guys, I should use percentile U, but I'm using percentile D. For unsigned number, what I should do? Go for percentile U, but I'm using what? Percentile D. Percentile D is for what? Signed, not for unsigned. But we are going for signed, sir. Your number is a positive number, which is the unsigned, and we are using percentile D. Any issue will come? No issue will come, sir. Why? Because you see, unsigned 65,535 will be there somewhere in this range, na? Will be there somewhere in this range, na? Similarly, if you come for the signed, there also it will be somewhere in this range. There also it will be somewhere in the range. So that is why whether you are using percentile U or percentile D, at least for positive numbers, no effect will come. No effect will come. But once the number will go beyond this value, na sir, when this number is go beyond this value, then automatically percentile D, percentile U will affect. Percentile D, percentile U will affect. But as long as it is a positive number, percentile D, percentile U will not have any effect. So that is why whenever I will print this one, guys, this A, which I should print with percentile U, I'm printing with percentile D, still it is not going to have any effect, and I will get 65,535. I will get 65,535. Next. Sir, complement of A should be given to K. Yesterday only I have learned, na, complement of operation. Currently, what is your A? This is your A. This is your A. Make it complement. Sir, before making it complement, do one thing, sir. Make the number as a 32-bit representation. Make the number as a 32-bit representation. What I need to do here? 1, 2, 3, 4, 5, 6, 7, 8. another 8 zeros. Another 8 zeros I added. Okay. So this is the number. Complement means, sir, all zeros will be converted to 1 and all ones will be converted to 0. All 1 will be converted to 0. This is my complement of A. This is my complement of A. Observe carefully, guys. This is my complement of A. Now, what is this number? What is this number? Are you ready to directly convert to decimal? No. Most significant bit is 1, sir. Now, as the MSB is 1, what to do? Let us take leaving the first digit. We have to take the remaining digits. Whose complement? What to do? Leave this one, guys. This is remaining digit, na? This is remaining digits. It's 2's complement I need to take, sir. But 2's complement is what? First go for 1's complement of this. 1's complement of this is, what will be the value, guys? Sir, here all will be 0, na? Yes. Here all will be 0. Then here all will be 1. And then again all will be 1. This is the 1's complement. Now, sir, I have to take 2's complement. What I have to do? Plus 1. What is the result for that? From here. What is the result for that? 110 with a carry 1. 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 Again. 110 with a carry 1. 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 Carry 1. Carry 1. Carry 1. Now that carry is here. Now the carry is here. Remaining up to this, all will be 0. Tell me, guys, any issue up to this? No. What is this number, sir? What is this number? 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096. Okay. 8192, 16,384, 32,768, 65,536. Super. 65,536. What is the number, guys? 65,536. Is it the final answer? No, sir. What is the final answer? Means the K value, guys. Means the K value. Final answer means I'm talking about K value. K is equal to, you assign now. What you are assigning? Complement of A to K. So now K is equal to will be what, guys? So that one I have to bring into the picture now. Minus 65,536. Minus 65,536. But K is a unsigned integer, sir. K is a unsigned integer. In a unsigned integer, forcefully you are assigning minus 65,536. In an unsigned integer where everything should be positive, in an unsigned integer where everything should be positive. Suppose, for example, guys, here, forget this for the time being. I'm taking one unsigned int I is equal to I'm taking minus 1. No, sir. It's not capable of taking minus value. It's capable of taking positive value. Still, I'm taking that. What will happen? What will happen? Sir, internally it will be considered this minus 1's equivalent value. So minus 1's equivalent value is what? This thing. So internally it will be considered this thing, sir. Even you write minus 1, internally it is considering this value. Really, sir? Really it is taking this value or not? Let's see. Can you prove that really it is taking or not? Print a percentile U. I'm writing I. Print a percentile U. I'm writing I. Execute, compile, and run. You need to keep this thing under comment line. Yeah. Compile and run. Execute, compile, and run. See this, guys. You given minus 1, but internally it is considering what? Internally it is considering what? Understanding, guys? Understanding? This is minus 1. This is this. This is what it is considering, sir. Sir, now what I will do? If I make it percentile D, what will happen? If you make it percentile D, what will happen? Internally, what it is considering? This value. Internally, what is considering this value? Now we are using which one? Format specification? Percentile D. That means you are asking, please print the value. Please print this value like a signed number, because you are using percentile D, format specification. Please print this value like a signed number. Then what they will do? It will print this like a signed number. If it is printing this like a signed number means what? If it is printing like a signed number means what? Minus 1 should come, na, guys? Minus 1 should come only. Execute, compile, and run. Understanding? Let's come back to our discussion. Up to this we have done. What is the K value, guys? Sir, minus 65,500. Where? Minus 65,536. But you are printing with what? Percentile D. Then which value should come? Negative of this will come, sir. If you go for percentile U, sir, then I don't know what will come. Minus 65,536 means somewhere it will be there. Somewhere it will be there. Minus 65,536 means somewhere it will be there. These equivalent numbers corresponding unsigned number will be printed. That is what number? How can I tell, sir? Then I have to go for numerical and manual calculation. Somewhere it will be there. That number's equivalent unsigned will be pick up and that will be printed. But currently I'm not doing that. Currently I'm printing with what? Percentile D. Oh, that means the negative itself will come, sir. That means the negative itself will come. Execute, compile, and run. Tell me, guys, understanding? Any issue? Any issue? Okay, na? Next. unsigned int a is equal to -1, unsigned int b is equal to 4. Here a left shift by b. What is the answer, guys? That means simple thing is that, sir, -1 left shift by 4. As simple as that, na? Negative number left shifting. Though we have learned yesterday what is the process, but even you can go for shortcut approach, na, guys. Even you can go for shortcut approach, na. If you go for shortcut approach, what will be the value? Tell me. What will be the value? Yes, -16 only. Achha, one extra thing is coming. Why? Execute, compile and run. Any doubt, guys? Any issue? Next. You have to tell me. Bring your pen and paper and you have to tell me what is the answer. (16 and 31). Okay. What about others? Ketan is telling, sir, 16 and 31. Let's see. Others? Can I start giving you the clarity? Okay. Sir, this is super easy. 32 right shift by 1. That means divided by 2 to the power 1. That means this is 16. No doubt about that. Where we will focus? Complement of yeah. See this, guys. M is equal to 32. 32 means 1, 2, 4, 8, 16, 32, na? 1, 0, 4, 0. 1, 2, 4, 8, 16, 32. Yeah, make it 32 bits. Currently, this is 8 bits. Next, 1, 2, 3, 4, 5, 6, 7, 8, 16 bits. Next. Next. 32 bit is ready. Complement. complement of m is equal to 1 1 1 1 0 1. Is this the answer? No. As the MSB is 1, we'll leave it and consider the remaining bits to complement. Remaining bits is what? These fellows. It's 2's complement I need to take. First, what you have to do? It's 1's complement is, let's go for it. Okay, 2's complement. 2's complement, this fellow plus 1. What is that result, guys? Almost same. Here will be 1. What is that value, guys? 1 2 4 8 16 32. Check it out. 1 2 4 8 16 32. Tell me, guys, what is the value here? Chetan, what is the value here? What is the value here? 1 2 4 8 16 32. What is the value? Others, everyone, what is the value? What is the decimal value for this? 33. Correct. 33. Is it the final answer? No. What is the final answer? Minus 33. This minus 33 will be printed here. So what answer we will get? For first one, 16. Next one, minus 33. Check it out. Execute, compile and run. Everyone understood? Everyone got the clarity? Tell me, guys. Are you understanding or not? Yes. Next and after that, one more. You have to tell me the answer. Unsigned int A is equal to -1. Unsigned int B is equal to 15. Printf %d A left shift by 1 %d B right shift by 1. You have to do it, guys. Yes, correct. Chetan, this time your answer is correct. But how you can do this with this much speed? This is okay. This is easily you can guess it. But this one, how can you do that with that much speed? Shortcut method you applied, na? Shortcut method you applied. Okay. -1. It actually means what? -1 left shift by 1. So -1 into 2 to the power 1. Yes, perfect. Execute, compile and run. -2, 7. Let me give some space here so that you can see that. Execute, compile and run. This is all about the shift operator, guys. So almost all the operators, whatever are existing, we discussed. Let me go for one more. Next week we will start flow control, guys. Int I is equal to 45, left shift 3, right shift 2, left shift 1. And I want to print that. What is the answer, guys? Let me show you precedence and associativity chart. Precedence and associativity chart. It's not there in my machine. Other machine, maybe I have that. Okay, no problem. I will show you that. I will share that chart with you. Precedence and associativity chart have to be followed here, sir. Left shift, right shift. Left shift, right shift. Both are having same precedence. Correct. Associativity is left to right. Associativity is left to right. Modulina, your answer is correct. So what I will do, sir? First this fellow. 40 right shift by 5. What is the answer? 1. Okay. Next, 1 left shift by 3. 8. 8 right shift by 2. 2. 2 left shift by 1. Super. Very easy, sir. Just the knowledge of precedence and associativity, enough. Super, na guys. People say that C programming language is very difficult. No, not at all. Depends on how you got the delivery. Based on that, difficult or easy, it comes in that way. Let me go for another one. I is equal to 10 greater than 9 greater than 7 less than 8. Tell me, guys, what is the answer? Yes, Chetan, your answer is correct. Yes. 1 is the answer. Execute, compile and run. Simple. Greater than, less than. Both are having same level of precedence. Associativity left to right. 10 greater than 9 returns what? 1. 1 greater than 7 returns what? 0. 0 less than 8 returns what? 1. Super. Last one. X is equal to 10, y is equal to 15. X XOR is equal to y, XOR is equal to x, XOR is equal to y. Printf %d %d xy. If you know this, immediately will react. Otherwise, you have to go for calculation. If you know the answer of this, then immediately will react. Okay, let me tell you. Swapping of two numbers, guys. Swapping of two numbers. So whenever we have done swapping of two numbers, we used to go for multiple approaches, using third variable, without using third variable, right? Among those options, one of the option is by using bitwise XOR also, we can go for swapping of two numbers. That is a possibility that can be done. How to do that, sir? This is nothing but the logic for that. It is called shorthand assignment operator, guys. This is called shorthand assignment operator. What it means, sir? Suppose if you are having x is equal to x plus 5, no need to write that. You can write x plus is equal to 5. You are having x is equal to x star 3. You can write x star is equal to 3. This is called, the star is equal to is called shorthand assignment operator. Less you have to write now, that's a shorthand. Now if you carefully look into this expression, it actually means x XOR is equal to y, y XOR is equal to x, x XOR is equal to y. This is the coding actually, sir. X XOR is equal to y. X XOR is equal to y actually means what, guys? X is equal to x XOR y. It means what, sir? Y is equal to y XOR x. And it means what? X is equal to x XOR y. X XOR y. Okay, na? Now you observe here. X XOR y. That is what you have to do. 10, 15. X is 10, sir. See this? X is 10. Y is 15. What we will do? 10 means, guys, 1 0 1 0. 15 means 1 1 1 1. But you have to go for what? 32-bit representation, sir. Always go for 32-bit representation. But it will take a bit time, na, sir. Are how many times you will do? Only once, na? Why you are worried about time? Every day you are going to do that? No. That means only one time. Or if it is one time activity, if it is taking a bit time, what is the problem? Done. Go for it first time. X XOR y. XOR means alternate gives us 1, sir. 1 0 1. 1 1 0 1 0 1 1 1 0. Alternate gives us 1, same gives us 0. Now what will happen? From here till end, everything will be what, guys? 0. Arrange. What is this number? What is this number, sir? 1 2 4. Okay, na? 1 2 4. 1 2 4. That means what? 5. Currently the value of x is 5. Next is what? Y is or x. This is my y. This is my y. XOR x. Currently x is what? 5. Currently x is what? 5. That means what? This. Go for it. One one. Same is 0. 1 0 1 1 1 0 1 0 1 0 1 na, guys? Yes. Remaining everything 0. 9 or 10. 9 or 10. This is equivalent to 10. Given to whom? Y. So y value will become what? 10. Last. What you have to do? X XOR y. X XOR y. What is y? What is y? 10. What is x? 5. Okay. So this is x. This is y. This is y. Current value of y is 10. Don't forget. Go for it. 1 0 1 1 0 1 1 0 1 1 0 1. Remaining all are you got the answer, guys? You got the answer? What is this? What is this, guys? 15. Given to whom? X. Lastly, x value is what? 15. Y value is 10. Initially x value was 10. Y value is 15. So ultimately what has happened here, guys? What has happened here in this coding? Swapping. Execute, compile and run. Okay, na? 15 and 10. Got swapping or not? Super. If anyone asks, write a program of swapping of two numbers in one line. I want the code to be written in one line. This is the logic. This is the logic to write the swapping of two numbers in one line. Thank you, guys. We will meet on Monday.